Hey everyone, if you're already familiar with this topic, feel free as always to just move on after looking at this screen, because this screen essentially has everything I plan on talking about in this lesson. So the first thing they teach you is the limit as x approaches positive or negative infinity of some constant c divided by x to the nth power is equal to 0. So that's interesting, but let's get some intuition behind this. Say c is some pretty big number, let's say it's 300. So we have 300 divided by what will always be plus or minus infinity. So we know that no matter how big c is, I could even add a couple zeros for effect, but no matter how big it is, it's always going to be infinitely less than infinity. So we know that this division thing will become really, really small. In fact, you can kind of tell by now that it's going to approach 0. So this makes sense. But let's look at the next problem. So now we have the limit as x approaches infinity, but now we have x's on both sides. Well, what we can do here is we can divide both the numerator and the denominator by the biggest degree of x. In this case, x squared. So now I'm dividing both the numerator and the denominator by x squared, so that just becomes 4 minus 2 divided by x. All of that divided by 3, because 3x squared divided by x squared is just 3. So this looks really familiar. This is a constant over x as x is approaching infinity. So this just becomes 0. So the limit here is just 4/3. That's easy to note. But now, oh no, now they have trigonometric functions in the numerator. This is terrible. But notice that for sine x at least, like there's a particular range of values it can go from. In fact, it's always going to be between -1 and 1. But x is going to be infinity. So, I mean, this is kind of like our constant case. So intuitively, we can tell that this has to become 0, because this is limited in a way. It's not going to be bigger than 1, and it's not going to be less than -1, but this is going to be huge. So dividing this by this will become 0. If you want a formal proof of this, by the way, you can look at the squeeze theorem. Or you can use the squeeze theorem to prove this. Also, guys, I would pay special attention to cases like this, because this will definitely show up on tests. Let's look at our last example. Oh no. There's the square root. Well, let's try factoring out that 4x squared in the square root and see what happens. So now I have a square root, and I'm factoring out the 4x squared. So now I have 1 plus, 3x squared. Simplifying just a bit. Okay, so this is still kind of messy, but let's take out the 4x squared now. So now I have 2x, square root of 1 plus, that looks familiar, it's 3 over x squared, so that just becomes 0. So we can just ignore this because it's multiplied by 2x. And then the numerator is still x plus 2. So now we have x plus 2 divided by 2x. And we know how to deal with this. We just divide by the biggest degree of x. So there's x, and that is the biggest degree of x. So we divide both sides by x. That just becomes 1 plus 2 over x. I bet you can tell what this becomes. Divided by 2. And so that just becomes 1/2. Alright, so that's not so bad. But now let's go into definitions, and don't leave yet, guys, but this isn't that bad. So the horizontal asymptote, I'm not going to go into the reading the definitions, because I think you guys can do that marvelously well by yourselves, but here's an example. Here's 1 over x. So from the first rule, we can tell that the limit as it approaches infinity or negative infinity is 0. So the horizontal asymptote is here, y equals 0. So you can see it graphically, it's kind of like that line that the function doesn't want to actually touch. It's like that kid that isn't so popular in elementary school. That's one way to think about it. And this is just a way to view it graphically. But now let's go into the oblique asymptote. So here's an example I think they gave in class. And here's that function plotted. So this only occurs when the numerator is exactly 1 degree greater than the denominator. So in this case, x cubed and x squared. 3 is greater than 2 by exactly 1, so this works. And the oblique asymptote is this. If you divide both sides by x squared plus 2, you get 4x plus 3. So thank you guys. Have a great day.